Welcome back. Today we will be talking about how to conduct a one-way ANOVA. A one-way ANOVA uses one factor across a dependent variable. More specifically, that one factor needs to have at least two or more categories with a dependent variable that's interval or ratio. So let's look at the data set. So our factors today will be flavor, and we have three different types of flavor: vanilla, chocolate, and strawberry. Our dependent variable is going to be ice cream cone calories, which, as you can see, is a ratio scale variable. So here's a scenario with the research question and hypothesis. Is there a difference in the number of calories across the different flavors of ice cream cones? Our null hypothesis: there is no difference in the number of calories across the different flavors of ice cream cones. An alternative hypothesis is there is a difference in the number of calories across the different flavors of ice cream cones. So, to see if there is a difference or not, we're going to conduct a one-way ANOVA. So there's two ways to do it. You can go to compare means, use the one-way ANOVA function there. But what I like to do is go to general linear models and use a univariate function. First, you put your independent variable or factor into the fixed factor section, and your dependent variable into your dependent variable section. A couple things I recommend doing is to include your plots. So I put my factor into the horizontal axis, add it, and I produce a bar chart. Because I have three categories for my fixed factor, I'm going to need to do a post hoc test. So I move my factor into the post hoc test. Now you'll see there's different types of post hoc tests you can run. The most common one that I've seen, at least in the field of psychology, is a Tukey test. However, I'm going to run a Bufferoni test because it has a more stringent threshold to meet to identify significant differences between groups. Also go to options to put your descriptive statistics. You want your partial eta square effect size and your homogeneity test. And as always, I always recommend to paste your syntax so you can have a running script of what analyses you conducted. Highlight it, push the green button, and there you go. So now, here are our results. As you can see, our ends are different in the sense that two of them are the same, and for strawberry it's different, only by one, so that's not going to be an issue. Another thing you want to look at is the means. You can see that vanilla has the least amount of ice cream cone calories, while strawberry has the most amount of ice cream cone calories. But the standard deviations are pretty similar, so that's a good thing. Then we look at our Levine's test, which is testing homogeneity. As you can see, our value is 0.56, which is good because if it's less than 0.05, then you violated your test of homogeneity, and you have to use a different type of correction if you want to interpret your results. But since our value is over 0.05, we can go on and interpret the results. Now we go to flavor, and we see that our value is less than 0.05, which means that there is a mean difference somewhere. We don't know where or between which categories, but we know it's there. Also, you can see our partial eta square is rather large. It's 0.734, which can be interpreted as that 73% of the dependent variable can be explained by the independent variable. Alright, so here are the multiple comparisons from our post hoc, and it compares vanilla to chocolate. You can see there's a significant difference. Vanilla to strawberry is also significantly different. And then we look at chocolate and strawberry, and that's also significantly different. And based on our plots, you can see that the values start to increase from vanilla to chocolate to strawberry. So you can see why there'd be a significant difference between the groups. So here's how you would report it in APA style. A one-way ANOVA was conducted to determine if there's a difference in the number of calories across the different flavors of ice cream cones. You always want to bring it back to your research question and your hypotheses. You want to keep that language very consistent so your reader knows that what you're reporting is based on what your hypotheses were. Ice cream flavors were classified into three groups. Vanilla, I report the sample size for vanilla, chocolate, and strawberry. The number of calories increased from vanilla. Here I report the mean and standard deviation to chocolate to strawberry. So giving your reader a visual and reminding them what the information is easier for them to understand what you're saying rather than having them go back to your tables to see what the values were. And then you remind them that the values were statistically significant with a difference between at least one of the mean numbers of calories, and you report your F statistic. So again, you're letting them know that there's a difference somewhere based on this test. More specifically, there was a statistically significant difference between vanilla and chocolate, between vanilla and strawberry, and between chocolate and strawberry. Oh, there's a typo. So identifying statistically significant differences between your categories is very important because it plays off of this model and it tells them where the differences were. So to get these values, you can get them from here, from this box where your degrees of freedom, 2 and 97 are right there. And your F statistic is right there. Your p-value is right there. And your partial eta square value is right there. Alright, so now you know how to conduct an ANOVA test. You know how to connect it to your research question and hypotheses. And now you also know how to report it in APA style. Thank you for viewing, and I look forward to providing you more resources and guides on how to conduct analyses using SPSS.